Light metering and autofocus modes. Light metering is not your grandfather's metering system anymore. Back in the day, we used handheld manual analog light meters. Today they still use light meters, only they are digital. However, today's DSLRs come with a pretty reliable digital light metering sensor built right in called metering mode, also known as camera metering, exposure metering, or simply metering. Knowing how metering works and what each of the metering modes does is important in photography, because knowing which mode to use for each situation will help your camera know how to handle it. That is what we are going to discuss in this tutorial. What is metering? Metering is how your camera determines what the correct shutter speed and aperture should be depending on the amount of light that goes into the camera and the sensitivity of the sensor. In the old days, because they worked in film and could not see the image they just took, they had to rely heavily on the handheld meter. Today we don't have to use the metering system. We can simply preview the image we just shot and determine whether we need to open up the aperture to let more light in or stop it down to let less light in. You could just tell by looking at the image or the histogram. But it is good to know how metering works so you can better control the outcome. Understanding metering will help you to take better photos and combat those difficult light situations. Today, every DSLR has an integrated light meter that automatically measures the reflected light and determines the optimal exposure. The most common metering modes in digital cameras today are evaluative metering or matrix metering, center-weighted metering, spot metering, or partial metering. When using these modes, it's useful to refer to the exposure meter display on the camera. The exposure meter display shows the result of the measurement taken by the light meter or the sensor. It will typically look something like this. Each number represents a stop change in the light, as indicated with the central mark being the correct exposure as determined by the light meter. Each pip between the numbers represents 1/3 of a stop. The arrow underneath indicates how close the current settings are to the correct exposure. Notice that if you point your camera at a very bright area, the bars will go to the plus side, indicating that there is too much light for the current exposure setting. If you point your camera at a very dark area, the bars will go to the minus side, indicating that there is not enough light. You would then need to increase or decrease your shutter speed to get to 0, which is the optimal exposure according to your camera meter. A camera meter is not only useful for just the manual mode. When you choose another mode, such as aperture priority, shutter priority, or program mode, the camera automatically adjusts the settings based on what it's read from the meter. Problems in metering. Camera meters work great when the scene is lit evenly. However, it gets problematic and challenging for light meters to determine the exposure when there are objects with different light levels and intensities. For example, if you are taking a picture of the blue sky with no clouds and no sun in the frame, the image will be correctly exposed because there is just one light level to deal with. The job gets a little harder if you add a few clouds into the image. The meter now needs to evaluate the brightness of the clouds versus the brightness of the sky and try to determine the optimal exposure. As a result, the camera meter might brighten up the sky a little bit in order to properly expose the clouds. Otherwise, the clouds would look too white or overexposed. What would happen if you added a big mountain into the scene? Now the camera meter would see that there is a large object that is much darker relative to the clouds in the sky, and it would try to come up with something in the middle so that the mountain is properly exposed as well. By default, the camera meter looks at the light levels in the entire frame and tries to come up with an exposure that balances the bright and the dark areas in the image. Evaluative matrix metering. Evaluative metering or matrix metering mode is the default metering mode on most DSLRs. It works by dividing the entire frame into multiple zones, which are then all analyzed on an individual basis for light and dark tones. One of the key factors that affects matrix metering is where the camera focus point is set to. After reading information from all individual zones, the metering system looks at where you focused within the frame and marks it more important than all other zones, making sure that area is exposed correctly over everything else. You should use this mode for most of your photography since it will generally do a pretty good job in determining the correct exposure. Center-weighted metering. Using the whole frame for determining the correct exposure is not always desirable. What if you are trying to take a headshot of a person with the sun behind them? This is where center-weighted metering comes in handy. Center-weighted metering evaluates the light in the middle of the frame and its surroundings and ignores the corners. Compared to matrix metering, center-weighted metering does not look at the focal point you select and only evaluates the middle area of the image. Use this mode when you want the camera to prioritize the middle of the frame, which works great for close-up portraits and relatively large subjects that are in the middle of the frame. For example, if you are taking a headshot of a person with the sun behind him or her, then this mode would expose the face of the person correctly, even though everything else would probably be heavily overexposed. Spot metering. Spot metering only evaluates the light around your focus point and ignores everything else. It evaluates a single zone or cell and calculates exposure based on that single area, nothing else. This is a good mode to use if your subject takes up a small portion of the frame and you want to make sure that that subject is correctly exposed. Also, if you are taking a picture of a person with the sun behind them, but they occupied a small part of the frame, it is best to use spot metering mode. When your subjects do not take up much of the space, using matrix or center-weighted metering modes would most likely result in a silhouette if the subject was backlit. Spot metering works great for backlit subjects like that. Exposing to the subject that is backlit could result in a very bright background, which can be a pleasant effect. If you wanted to maintain the detail in the background, you could fill flash your subject. Another good example of using spot metering is when photographing the moon. Because the moon would take up a small portion of the frame and the sky is completely dark around it, it is best to use spot metering. That way, we are only looking at the light level coming from the moon and nothing else. Some DSLRs like the Canon 1D and 1DS are capable of multi-spot metering, which basically allows choosing multiple spots to measure light and come up with an average value for a good exposure. Partial metering. Some Canon EOS models also offer partial metering, which is similar to spot metering, except the covered area is larger, approximately 8% of the viewfinder area near the center versus 3.5% in spot metering. Exposure compensation. Even though the light meter in your camera is pretty sophisticated, sometimes it can get it wrong, especially with harsh contrast or high reflective surfaces. Changing metering modes may help this, but a more controlled approach is to use exposure compensation. Imagine you are photographing a person against a large bright sky. The light meter thinks the sky is the most important part and exposes correctly for that, leaving the person a dark silhouette. By using exposure compensation, you can tell the camera to take the metered exposure and make it brighter by a chosen amount. This will then allow the photographer to correctly expose the person. Autofocus modes. AF. Autofocus. The lens automatically focuses on the subject as quick as the eye. There are several autofocus settings. With your lens switched to autofocus, these options will become available. AI Focus AF for Canon and AF-A for Nikon, which stands for Automatic Autofocus. In this mode, the lens is set to autofocus, and the camera's focusing computer jumps back and forth between one shot and AI servo as needed. AI servo stands for continuous focus, and this mode is most useful for keeping moving objects sharp within the viewfinder as you track the object. As soon as you begin to press the shutter release or the back shutter button, the camera goes into action and begins to focus. In continuous focusing mode, the camera detects the subject's movements and focuses accordingly to keep the object sharp as attack. This mode uses a lot of battery power because it is continuously focusing and refocusing. This is good for tracking a bird or a bicycle coming towards you during a race. One-shot AF or AFS, which represent single focus capability. In this mode, when you depress the shutter release halfway, the camera focuses on the subject just once. There's no continuous adjustment. This mode saves battery power and is ideal for subjects that aren't moving. However, this mode falls short when you're trying to capture something that's changing positions. So unless you're trying to get a quick shot of a deer in the early morning, then one-shot mode is probably your best bet. Pinpoint accurate focus. When composing a shot, we tend to offset our subjects because it is just more appealing to look at. It is more artistic and can actually bring more attention to your subject. In the photo of my cat coming towards me, and fairly quickly I might add, I had to focus quickly. To do that, I took advantage of the adjustable focusing point by placing it over her in order to maintain focus on her as she moved. I actually used manual focus, as I often do and am used to, but this would have been a perfect situation to use AI servo mode. My camera would have been able to automatically track her as she came towards me, keeping the focus on her and not on the very bright leaves. So I was able to isolate what I wanted to focus on by selecting the exact focal point I needed. This takes getting used to, knowing your camera very well so you can do it on the fly without thinking. Back button focus. Back button focus is something I think is worth mentioning because I find it extremely convenient. In fact, I don't know why it is not the default setting, but it may be a little more advanced than you are ready for if you are just getting used to your manual settings. Once you get used to it though, you will never go back to the shutter button focusing. Both Canon and Nikon have this convenient custom function. Just what is back button focusing? Traditionally, the camera usually focuses when the shutter button is pressed halfway down, and then the photographer takes the picture when the button is pressed in fully. Back button autofocus makes it so the shutter button doesn't control the focus activation at all, but instead assigns another button on the back of the camera to activate focusing. Below are a couple of scenarios that will explain why back button focusing is so great. No more switching your lens to manual focus to lock it in. A lot of the times, we find we need to focus and recompose a shot. First, you have to autofocus on your subject, then switch the focus back to manual focus so not to lose it, and then recompose and take the shot. With back button focus, the shutter becomes just that, and only that, a shutter button. The AF on button on the back of the camera is now the dedicated autofocus button. You can now focus on your subject and it will stay focused while you recompose and snap the shot. The shutter isn't pressed until it is time to actually take the photo. No more focusing every time you let go of the shutter. This was one of the most frustrating things I ran into when I used the shutter halfway down method of focusing. Sure, you can lock in focus by holding the shutter halfway down, then focus will stay locked as long as you hold your shutter in limbo, but then you have to hold your finger there while you recompose. If you let go or accidentally lift your finger just a little bit, the camera will refocus as soon as you press it down again, or press the shutter button a little too hard and you will take a picture before you're ready. With back button focus, you can set focus and it will stay set until you decide to change it. Again, you don't have to touch the shutter until you are ready to take the picture.